Welcome to the DIY Honda Garage channel. The DTC P0326 signifies a malfunction in the knock sensor system of the Honda Accord models from 2012 to 2017. The knock sensor is a vital component, often located on the engine block, typically near the cylinder head. Its primary role is to detect engine knocking or pinging, which can occur due to issues like improper fuel combustion. This sensor transmits signals to the Engine Control Module, ECM, allowing it to adjust ignition timing for optimal performance and efficiency. A malfunction can lead to reduced engine performance, increased emissions, and even potential engine damage if not addressed. It's crucial to follow a systematic troubleshooting approach to diagnose the issue effectively and rectify it. To conclude the diagnostic process, a test drive must be conducted under specific conditions, ensuring the optimal performance of the knock sensor. During the test, the engine coolant temperature should exceed 158 degrees Fahrenheit, 70 degrees Celsius, to guarantee that the engine is operating under normal conditions. For models with automatic transmissions, it should be in drive, while manual transmissions should be positioned in fifth gear during testing. The engine speed should reach at least 1,500 RPM, accurately simulating normal driving scenarios. This test drive checks whether the DTC reoccurs under these conditions, revealing whether the issue has been resolved. Observing the vehicle's performance during the drive will provide further insight into the effectiveness of the repair and sensor functionality. The final verification step involves checking for any pending or confirmed DTCs using the Honda Diagnostic System, HDS. After all repairs have been conducted and the test drive completed, this step ensures that the DTC P0326 does not reappear. If the HDS indicates that DTC P0326 or any other fault code is present, further diagnostics may be necessary to identify lingering issues such as wiring problems or poor connections. Successfully confirming the absence of DTCs reassures the technician that the repairs made were effective and that the knock sensor system is now functioning as intended. It is crucial to document all findings and repair actions to ensure complete transparency and accountability. To prevent future occurrences of DTC P0326, regular inspections of the knock sensor and related components should be scheduled as part of routine maintenance. Ensuring that the sensor is appropriately installed and properly secured will help prevent improper readings and malfunction in the future. Monitoring engine performance for any abnormal sounds or noticeable changes in efficiency can alert drivers to potential issues early on. Additionally, keeping the wiring harnesses and connectors free from corrosion and damage is key in maintaining electrical integrity. Establishing a proactive maintenance routine can greatly enhance overall vehicle reliability and performance, ultimately extending the life of the knock sensor and the engine. In conclusion, troubleshooting DTC P0326 in the Honda Accord involves a systematic approach that includes checking the knock sensor installation, ensuring proper connections, and resetting the PCM. Identifying any underlying causes, like faulty wiring or poor connections, is essential to effective repairs. Symptoms of the issue typically manifest as reduced engine performance or abnormal sounds, emphasizing the need for prompt corrective action. Successfully conducting the test drive and final verification steps ensures that the issue has been resolved. Regular preventive maintenance can further safeguard against future occurrences, enhancing the long-term reliability and efficiency of your vehicle. The knock sensor is responsible for monitoring engine vibrations caused by knocking, which is typically the result of improper combustion. In the Honda Accord, it is usually installed on the engine block or cylinder head, an area where it can effectively sense vibrations. If the knock sensor is malfunctioning, the ECM may not receive accurate information, leading to poor ignition timing and fuel efficiency issues. The sensor plays a critical role in maintaining optimal engine performance by adjusting parameters based on its readings. A failure in this component can cause issues such as a decrease in power, knocking sounds during acceleration, and elevated emissions. Understanding the role and location of the knock sensor is vital for effective troubleshooting. Several possible causes can lead to the activation of DTC P0326. First, the knock sensor may not be installed correctly, which can impede its ability to function properly. Second, the sensor itself could be faulty due to wear and tear or manufacturing defects. Loose connections or terminals at the knock sensor or the powertrain control module, PCM, may also prevent reliable data transmission. Additionally, a damaged wiring harness could disrupt the sensor signals to the PCM. Lastly, if the PCM has been updated, it may not communicate effectively with the existing knock sensor, causing malfunction codes. Diagnosing each potential cause is crucial for an effective repair. Drivers may notice multiple symptoms when DTC P0326 is triggered. A common sign is reduced engine performance, as the vehicle may not accelerate as desired due to improper timing adjustments. Additionally, the engine might produce knocking or pinging sounds, particularly during acceleration or under load, indicating abnormal combustion conditions. Increased emissions may also occur, resulting from inefficient fuel combustion, which could eventually lead to failing emissions tests. The check engine light is likely illuminated, alerting the driver to potential engine issues. Lastly, owners may experience poor fuel economy as the ECM struggles to maintain efficient engine operation. Addressing these symptoms promptly is not just about performance. It's crucial for the vehicle's long-term health. The first step in troubleshooting DTC P0326 involves checking the installation of the knock sensor. It's essential to confirm that the sensor is positioned correctly on the engine block or cylinder head, as even slight misalignment can lead to malfunction. During this check, also examine any surrounding components for signs of interference or damage that could affect the sensor's functionality. If the installation is found to be correct, the next step involves verifying the sensor's operability. However, if the installation is incorrect, it must be reinstalled properly before moving on to further diagnostics. Proper installation is fundamental for ensuring that the sensor provides accurate data to the ECM. After confirming the installation, the next step is to reconnect all electrical connectors associated with the knock sensor and the PCM. Loose or corroded connections can significantly impact the sensor's operation and may lead to intermittent DTC codes. Each connection should be checked for corrosion, which can hinder electrical flow and affect the sensor's performance. Ensuring that all connectors are firmly in place will help provide a stable and accurate signal transmission to the PCM. Once all connectors are securely reattached, testing can proceed to evaluate whether the DTC persists after reconnections. This step is critical, as addressing connection issues can often resolve the problem without further complications. The next step in diagnosing DTC P0326 involves turning the ignition switch to the on position. This can also be accomplished by pressing the engine start-stop button if equipped. It's essential to ensure that the ignition is in the on mode without starting the engine. This action allows power to flow to various vehicle systems, including the ECM, which will be crucial for the subsequent diagnostic steps. A stable power source ensures the electronic systems can communicate properly. This step is foundational to resetting the ECM parameters, which may have been affected by the previous knock sensor malfunction. Correctly executing this step prepares the vehicle for any necessary resets and checks. Resetting the Powertrain Control Module, PCM, with the Honda Diagnostic System, HDS, is crucial for clearing past DTCs and providing a fresh start for the engine management system. The HDS is a specialized tool that allows technicians to communicate with the vehicle's internal computer systems, including the PCM. By performing a reset, any lingering errors related to the knock sensor can be cleared, allowing for new data to be gathered. After the reset, it is advisable to clear any logged DTCs to ensure that only current codes are displayed during testing. This step allows the vehicle to initiate a new learning cycle for the engine operating conditions. Without this reset, erroneous data could lead to continued diagnostics and misleading repair steps. Once the PCM has been reset, it is essential to perform the PCM idle learn procedure. This process allows the PCM to adapt to optimal idle speeds and engine parameters after any changes have been made. Monitoring the engine's performance during this procedure is crucial to ensure that it runs smoothly without issues related to idle speed. The idle learn procedure may take several minutes, during which the vehicle will need to remain in ideal operating conditions. Observing key parameters, such as coolant temperature and engine speed, will be vital during this phase. This ensures that the PCM effectively learns the new conditions, preparing the vehicle for normal driving scenarios and optimizing overall performance. Please like and subscribe to the channel. See you next time.